Hello students, welcome to the next lecture on this Jacobi method. Today we will describe the various examples on this Jacobi method. We are explaining the 10 examples with the two different methods so that you can easily understand it very well. Myself Dr. Harish, you can simply follow my YouTube channel for various lectures on this numerical analysis. So what is the Jacobi method? As we described the basic concepts of the Jacobi method in our last lecture. And here the Jacobi method is an iterative method for solving the for finding the approximate solutions of the system of equation Ax is equal to b. What is the meaning of the approximate solution or the iterative method? It can start with the initial guess as a x0, then we can find the updated value as a x1. Based on this x1 we can find the new solution as a x2 and so on until your desired accuracy met. What is the desired accuracies? It may be the 10 raised to power 3, it may be up to the 3 decimal places or up to the 5 decimal places. Relative error should be less than of some tolerance and so on. I will teach you the two different methods how you can solve this system by using the Jacobi method. The first method is, if you have the system Ax is equal to b, make sure the matrix A should be the diagonal dominant. What is the property of the diagonal dominant? If you look about the any of the row, that is the absolute value of the ith row or the diagonal entries must be greater than or equal to the remaining entries Aij, where j is 1 to n and I is not equal to j. That means if you consider about A11, absolute value of the A11 must be greater than of this remaining element A12 plus A13 plus so on up to the A1n. Similarly for the second row, similarly for the nth row. If make sure firstly it should be the diagonal dominant. If it is a diagonal dominant, then only this method is applicable, otherwise not. Then we can find the value of the x1 from this, which can be written as b1 minus of a12 x2 and so on divided by a11. Similarly you can find the value of the x2 from the second equation, xn from the last equation, like of this. Similarly you can find the value of the x2 and xn. What is the second method is, again if you have the system here, I can decompose the system into the three parts: lower, diagonal and the upper, which is the strictly lower, strictly upper. Fine. So what is the meaning of the strictly lower and upper? If you have the 1 2 3 4, then what is my diagonal matrix? That is only the diagonal values. Fine. What is the lower values? Because it's a strictly, so you have to consider only for the strict value while the rest values are 0. What is the upper is? The diagonal values must be 0, lower is 0 and only for the upper value. And you can see when you add them, it becomes my A. Then I can substitute this value of the A as here. Then you can solve this, you can get the expression this, as I told you earlier in this previous lecture. Now, once you can get either of the method, like either of this or this, we can start with the initial approximation x0. I can take this value of the x1, substitute here, x2 and so on. I can find the new value of x1. I can find the new value of the x2 and so on. Similarly, if I substitute the value of here, I can get the new value of the x1, x2 and here we can call as the x1. Now based on this, I can substitute this updated value again in these equations. We will get as this values. We will see the couple of examples so that you can understand it very well. But remember, because this method is the iteration method, so what is the condition for the convergent? A very simple target. You have to consider the two matrix firstly. Firstly check whether A is a diagonal dominant or not. If it is a diagonal dominant, then the system is convergent for any initial approximation. What is the meaning of the any initial approximation? That means either you can start with the initial approximation as 0 0 0, either you can start with the initial approximation as -1 0, either you can start with the initial approximation as say 0.5, -0.3, -0.7 or +0.7 and so on. You can take any, but make sure the first one is a diagonal dominant. If it is not a diagonal dominant, then we will think about the spectral radius of the H. Spectral radius is denoted by rho of the matrix H. This H is called as the iterative matrix. This matrix is called as iterative matrix, because we are talking about the Jacobi method. So this method is called as the Jacobi iterative matrix. Then we can take the H. Well, how you can find the spectral radius? Spectral radius is nothing but the maximum eigenvalue, maximum absolute eigenvalue of this. Look at the couple of examples so that you can understand it. So solve the following equation by Jacobi method. What is the first step is, you need to check whether it's a diagonal dominant or not. What is the property of the diagonal dominant? Look at the first diagonal value. It's a 15. Take the absolute value of 15. Is it greater than or equal to the rest of the value, like 3 and minus of 2? Yes. Similarly, look at the second one, 10. Is it greater than of 2 plus 1? Yes. Look at the third one. Third diagonal value is 8. Is it greater than or equal to 1 plus of minus 2? Yes. So since all these three equations satisfied, so we can say this is a diagonal dominant. Hence, once it's a diagonal dominant, so Jacobi method, if you apply, it will be give a convergent solution. Now, since Jacobi method is an iterative method, so we can find the value of the x1 from the first equation. We can find the value of the x2 from the second equation, x3 from the third equation, which come to be here. Or you can write in terms of the iterative manner. Here I can write in terms of iterative method. This is the n plus 1, this is the nth, this is the nth, and so on, like of this. Now since it is a convergent, so we can start with, we can complete this table. Remember, your target is to complete this table and you will get the required answer. This is one of the easiest way. Now since I can take the initial approximation as here, because this is my diagonal dominant, so you can take any of the x naught. You can take, this is my x naught. You may start with the 1 1 1. You may start with the 1 minus 1.3, because it's a diagonal dominant, so the method is always convergent. So how you can find the solution? I can take as a 0 0 0. Fine. So what you can do is, I can substitute this value 0, y is 0, my 0 0 0. The first value is my x, second is y, third is z. I can substitute value here. So what is the first value is 85 over 50. I can substitute the value of the x and z from here. It is my 5.1. I can substitute the value of here. It will be my 5 divided by 8. Now you can write all this calculation with the at least 4 decimal places. If nothing is mentioned you in the statement, then at least the 4 decimal places to be here. Then I can start with this. Now again I can substitute these three values here. What is the value of the y? So this is 1 over 15. 85 minus 3 times y. Now the updated value of the y is 5.100 plus 2 into z. So 0.6250. You can use the calculator. The value of the answer will be my here. Similarly, I can find this value here, 1 over 10, 51 minus 2 into x. X is my previous value. Always remember, the previous value is here, minus z, 0.62 as here. We will get this value. Similarly, I can substitute here. We will get this as answer. Now, again, because you can see these two values are not same up to the 3 decimal places or the 4 decimal places, I can find the new value. I can take the value of y as here, value of the z at here, substitute this value, we can get this answer. I can substitute the value of the x and z, I can substitute here, you will get this answer. Clearly says this, again the 4 decimal places are not matched, so we can find this and so on. Again you can see up to the 8th equation the decimal places are matched, so we can see the desired root is my here, or the desired solution is my. You can also check your answer in the examination. If you substitute this value, say in the last equation, 5 minus 8 plus 8, you can see the 5 satisfied. Again you can substitute here 10 plus 40 plus 1 is a 51. You can also see here 75 plus 12 minus 2, which is my 81. Again is the 85 is the right answer. This is the first method. On the other hand, if you apply the second method, you have to need the value of the h and the c. So from here, this is my a. I can find the value of the D, which is the diagonal entries. I need the value of the L plus U. So L plus U is nothing but apart from the diagonal entries. Can you find the D inverse? So there is a very simple, you can simply take the reciprocal of this. 1 by 15, 1 over 10, 1 over 8. Rest values are my 0. Fine, this is my D inverse. Now we can substitute the value of here. So what is the H is? Minus D inverse of L plus U. So you can multiply the two matrix. Otherwise it's a very simple. What you can do, I can simply write the first value, multiply the first value with the first value is a 0. Fine. Multiply this value with this, it is a 1 over 5, is a 1.2. Multiply this value with the first value, it's a minus 2 over 50. Fine. Similarly, look for this second case, that is a second row. I can multiply first value with this value, is a 0. Second value with this, and so on, you will get as this answer. Otherwise you can simply do as usual multiplication. And this is my D inverse, this is my B. You can simply multiply again. You can simply multiply this value with the 85, it comes to the 5.6. 1 by 10 into the 51 is a 5.1. 5 into 5, 1 by 8 is my here. Now I can substitute both the values of the H and C at here. Fine. Then you can start with the iterative process. I can start with the X naught randomly. I can substitute this value here. You can use your calculator. Remember, in the calculator you can write the matrix AX plus B. Fine. This matrix is a constant. This is my constant. You can change your answer and you can substitute your answer like mat ANS in your updated X. If I substitute X is my 0, 0, 0, then you will get as this answer. Then I can substitute this value at here. If you multiply this matrix and addition, you will get this value. Again, you can see that 4 decimal places are not matched. You can find the X3. Again, you can see the 4 decimal places are not matched. I can substitute this value here, multiply the two matrix, and you will get this as here. Again, the two matrix are not same. I can substitute here. You can see they are approximately same, but not exactly same. I can find the new matrix X8, which comes to be here, which as the required solution. And you can see by both the method, matrix 1 and matrix 2, the answers of the X1, X2 all are my always same. Now look at this second question. Now up to the 3 decimal places. Firstly, check whether it's a diagonal dominant. Look at that 1. Is it a greater than of the 2 plus 1? No. It means this is not diagonal dominant. It is not diagonal dominant. Why? Because this first two equations not satisfied. So your target is to make the diagonal dominant. How you make them? You can simply rearrange the equations. Can you rearrange the equations so that it becomes a diagonal dominant? Yes. If I consider this is my first equation, this is my second, I can simply change the first and the second. Now you can see 3 is greater than of the 1 plus minus 1. Satisfied? Look at the second, 2 is greater than of the 1 plus minus 1. Satisfied? Third is 4 is greater than of the 1 plus minus 1. It's satisfied. So therefore it's a diagonal dominant. Once it's a diagonal dominant, so the Jacobi method will converge for any guess. I can find the value of the X1 from here. I can find the X2 from second, that is the Y from the second, and the Z from the third. Then our target is to complete this. I can start with any initial approximation. Let's say this time is a 1, 1, 1. So if I substitute here, what is the value of this? 0. If I substitute here, is a minus 1. If I substitute 1, 1, it's a 3 by 4 is a 0.75. Then I can substitute this value again here. It will be 1 over 3. Z is my 0.75. Y is my minus plus 1. So this is my 1.75 divided by 3. I can substitute this value. X is my 0. Z is my 0.75. So you can see it's a minus 0.375 and so on. Fine. Now similarly, you can, this is my Y. This value is my Y. So this value is written at here. Similarly, I can substitute here. You will get Z as 0.5. Now clearly says these two results are not up to the 3 decimal places. We can find the third equation. Substitute the value of the y, substitute the value of the z at here, we will get the new value. Similarly for this. Again you can see up to the 3 decimal places they are not match. We can find the next equations. Again you can see they are not match. Again I can substitute here. We can find the value of the x6. Again you can see they are not match up to the 3 decimal places. I can substitute this x7 values here, here and here. We will get this one. Now you can see up to the 3 decimal places it match. It is also match. It is also match. So we can see this is my correct solution of this equations. Fine. Look at the another matrix, another question. Check whether it's a diagonal dominant. So you can see 20 is greater than of the 1 plus minus of 2. Then clearly say this is a diagonal dominant. Once this is a diagonal dominant, then it means the solution will be convergent for any initial value. For any initial value. So find the value of the x from the first equation, find the value of y from the second, and the z from this third. Then our target is to make this table. You can start with any initial guess. So say 0, 0, 0. Your answer first one will be 0.85. X and z both are 0. It is my minus 0.9. And if you substitute here, it will be my, what is the answer is 0.5. Sorry, 0.125. So you can see 0.125. I can substitute these new values at here, this and this. I can get the updated value. Clearly say the results are not match up to the 3 or 4 decimal places. We can find here. Now you can see this value is first decimal places match while others not. We can see here. Clearly says the result are match up to the 4 decimal places. So we can see the solutions is my here. You can also check your answer by substituting this here. You can see whether they are satisfied or not. We can solve the same question with the second method like of this. We can find the matrix capital D, which is the diagonal matrix. L plus U is apart from the diagonal. What is the D inverse? I can simply take the reciprocal of this value. Rest values are my 0. Fine. Then I can simply take this value. So I can find the value of the h. I can simply take multiply of this by here. The first value will be 0 with the negative sign because of this negative. Second with this, it's a 1 by 20. Third, minus 2 into 10, it's a minus 1 by 10. Similarly, for the second row, I can start with this and so on. You will get as this matrix. Second row with this second value. Third row with the third value and so on. Otherwise, you can simply take the two matrix multiply. I can substitute this value of the h and c at here. Your iterative scheme is my this. Then again, you can start with any initial approximation because you can save this value on your calculator. I can take as a 0, 0, 0. Then if you multiply them, you will get x1 as here. Substitute this value at here. Is a column vector. Multiply the two matrix. You can use your calculator. You can get your answer within a 10 second. You can use your calculator matrix here. Then I can substitute this x2 as here. Now you can see 3 decimal places are not matched. I can find the value of the x4. The value of the x4 and x5 are here. You can see up to the 4 decimal places they are approximately matched. So the desired solution is my again the same. Look at the another one. Apply the Jacobi method for solving this until this condition hold. Check whether it's a diagonal dominant or not. So 4 is greater than of the 1 plus 1 satisfied. 7 is greater than of the 2 plus 1 satisfied. 12 is greater than of the 1 plus 3 satisfied. So this is my diagonal dominant. So it means Jacobi method is applicable. We can find the value of the x, y and z from the first, second and third. Then your target is to complete this matrix. Take the initial approximation as a 0, 0, 0. The first value will be 0.75. Next value will be 19 by 7 and so on. How you can find this value? Look at that. This is a norm. What is the definition of the norm of infinity? Is maximum of xi. Look at that. If I take about the numerator, what is the value of the xn? That is the first minus second. So it means 0.75 minus 0 is a 0.75. 2.7143 minus 0, 2.5833. This is the value of the numerator. Take the norm, that is the absolute, take the absolute value and the final maximum value. What is the maximum value of this is 2.7143. Fine, this is the numerator. What is the denominator is xn, n is 1. What is the maximum value in the absolute is 2.7143. So the answer is my 1. Now I can substitute this value of the x, y and z in here. I can get this new value of this. Then I can find the difference of this. You can see 0.7173 minus 0.75. Second is 2.1310 minus 2.7143. And the third one is 3994 minus 2.5833. So you will get answer, and here. Then take the maximum of this in the absolute, that is my numerator. What is the denominator is, take the absolute value of this and the maximum. The maximum is my 3.994. You can take the subtraction and find the absolute value in maximum and then take the ratio, you will get this number. Since this ratio is not less than of the 001, 0001, so we can find the third iteration. Substitute this value at here, you will get this answer. Now take the difference of this two consecutive numbers, find the value, absolute value in the maximum and divide it by this one. You will get this number. Again, this is not less than of the 0001, we can find the fourth iteration and so on. Now again you can see this number is not less than of the 0001, we can find the seventh iteration. Substitute the sixth iteration value at here, you will get this number. So clearly says this number is less than of 0001. Is it true? Sorry, it's a 001. So this number is less than of the 001. So it means we can stop the process and you can get the right answer as here. Look at the, okay, you can also solve this question with the matrix method like of D inverse of L plus U. You can also solve this question with the help of the second method. Okay, look at this next question. The system of the equation is solved iterative by here. A is given to be this. Find the condition on the K so that Jacobi method will converge. Now, so what is the condition for the convergence? You have to find whether it's a diagonal dominant or not. So what is that? Is 1 is greater than K and the second is 1 is greater than the 2K. We are not sure about that because K can be 7, K can be 0.1. If it is a 0.1, then it's satisfied. But if K is equal to 7 or 9 or 5, then it is not true. So since we are unable to know about the K, so what you can do, how you can find this? We can find the spectral radius. Fine. So the convergence condition is spectral radius is less than 1. What is the spectral radius is? Maximum value of the eigenvalue of the matrix H. If I take the absolute value of the maximum value, it must be less than of 1. What is the H? H is my here. So your target is to firstly find of this. So what is the diagonal matrix? 1, 1, 0, 0. What is the L plus U? L plus U is apart from the diagonal matrix, that's a 0, 0, 2K and K. Fine. Then I can find the D inverse of L plus U. What is the D inverse? So reciprocal of this is 1 by 1, it's a 1 over 1, 0, 0. I can multiply these two matrix. Why is a minus? Because of this negative. So if you multiply them, it's a 0, it's my minus K, it's my minus of 2K and it's my 0. Fine. Now you find the eigenvalues of this. You can start from here. Now I can substitute this value. What is the determinant of this? Lambda square minus of 2K square is 0. So can you find the value of the lambda? It is plus minus of this. That means the first value is my root 2K. Second value is my minus of root 2K. So you have to find the maximum value in the absolute. What is the absolute value of the maximum is? Root 2K must be less than of the 1 is the required condition. So the necessary and sufficient condition for the matrix, this is a convergent by Jacobi when K is less than of 1 by root 2. Look at this another question. You have to perform the Gauss-Jacobi method by performing only the 3 iterations and start with this initial guess instead of the 0 0 0. Check whether this is a diagonal dominant or not. So clearly says 4 is greater than of the 2 plus 1. Fine. 3 is greater than of the 1 plus 1. And 6 is greater than of the 3 plus 2. So that means it is my diagonal dominant. So it means the solution is convergent for any initial guess. For any initial guess. You can take the initial approximation either as here. You can take initial approximation either as my this. You can take any of the value. So you can find the value of the x1 from this, x2 from this, and x3 from the third equation. The target is to complete this table. So since we need the 3 equations only, so I can make this table. Substitute the value of the x1. This first value is my x1, x2, and x3. Substitute the value of the x2 and x3 here. You will get the first value this. Then I can use this value of the x1, x2, and x3 in here. You will get the next value as this. Substitute in the third equation, you will get this as here. You can solve the same question either even the second method as well. So the required approximate solution is this is the solution. We can solve the same question with the help of the matrix method as well. We can find this value. Firstly, D and L plus U is my here. What is my D inverse? You can simply take the reciprocal of 1 by 4, 1 by 3, 1 by 6. Rest values are my 0. Then you can simply multiply these equations. You will get, again as I told you, take the first value, multiply individually. 0 into 1 by 4 is 0. 2 into 1 by 4 is minus. Why is a negative? Because of this negative sign. And 1 into 1 by 4 is my here. Similarly, you can take this value and multiply with this second and so on. So I can substitute H and C in this equation. So now you will get as here. So now we can take the initial approximation as given. Substitute this value at here in the form of the matrix. Multiply the two matrix, you will get this answer. Similarly, take this, you will get these two are the results. So since we need to perform the 3 iterations, so these are my final answer of this problem. Look at this another one. Check whether it's a Jacobi matrix or not. So again you can see 27 is greater than of the 6 plus 1. 15 is greater than of the 6 plus 2. 54 is greater than of the 1 plus 1. Remember, if it is not a diagonal dominant, you have to make them a diagonal dominant. If still it is not a diagonal dominant, then you have to find the spectral radius. Fine. If the spectral radius of the matrix H is less than of the 1, then you can say the Jacobi method will converge. Now in this case it's a convergent. So we can take the value of the x from the first, y from the second, and the z from the third. So take any of the initial vectors, say this. I can substitute this value here. The first value will be 85 by 27. Second value is 72 by 5. Third value is 110 by 54. I can substitute this value in these again equations. You will get this new updated value. Since the results are not matched up to the 3 or the 4 decimal places, we can find the third equation here. Again you can see the results are not matched up to the 3 or 4 decimal places. You can find the next 4 values. Clearly says the result is matched only up to the 1 decimal places. So we can find the 6th equation as well. Now you can see up to only the 2 decimal places are matched. But we need at least 3 or 4 decimal places. So we can find the 8th equation as well. Now you can see up to the 3 decimal places it match. Approximately they are up to the 3 decimal places, and they are again same as here. Otherwise you can find the 10th equation, you will get the same result of this. So my approximate solution is my here. You can also solve the same question with the help of the second method. You can do it by OR. Or I can show you here. We can find the value of the D. I can find the value of the L plus U. You can find the D inverse. And you can multiply this first value with the first row, second value with the second row, third value with the third row. You will get as here. Substitute this, you will get this. Then you can start with the initial approximation. Substitute this value here in the matrix format. You will get x1, x2, x3, x4. Again you can see the decimal places are not matched. We can find the x6, x7, x8 and x9. and you can see they are matched up to the 3 decimal places. Your required solution will be here. So it will take a very less time if you are using the calculator very frequently. Look at one more example here. So check whether it's a diagonal dominant. So you can see 4 is greater than of the 1 plus 1, 5 is greater than of the 1 plus 2, 3 is greater than or equal to 1 plus 2. So all are satisfied, hence it is a diagonal dominant. So it means the Jacobi method will applicable and you can get the solution here. So we can find the value of the x1, x2 and x3 from the first equation, from the second is x2 and the third from the x3. Take any initial vector, but the initial point is given to you as here. Now you have to perform only the 3 iterations. Substitute this value at here, you will get the first answer this. Substitute these 3 values in this equation, you will get x2 and so on. So the final answer will be these are the after the 3 iterations. Although this is not the exact root, that's why this is an approximate root. So this is the way you can solve this Gauss elimination method in a very simple method. We will see the next class on the gauss-seidal method, how you can solve them. Till then, you can simply like, share and comments on my video. Best of luck students. Happy learning.